Lay down your bundles of rags and reminders and spread your wares on the ground. Well, I've got time if you deal in rhyme. I'm just hanging round. Meet me on the corner. Yeah, still really haven't finished with this air pressure thing. There's many ways to look at it. I've said before that I boil my kettle, and it's on right at the moment, so be prepared. Using gas, Calor gas, or, well, that's the trade name, I suppose. It's butane gas. And okay, the pressure might be equal on the sides of that, internally on the sides of that cylinder. But just think if the cylinder would remain the same diameter, but was 200 miles, sorry, not 200 miles, that's a bit much, say 20 miles tall. Now, just think about that for a moment, imagine it, picture it in your mind, and then think of the contents. Now, we're talking about the Earth, of course. It's standing on the Earth. Let's just say it's at sea level. The base is at sea level, and it goes 20 miles up into the air. Now, even in a normal-sized gas cylinder, when it's half full, there is gas at the top and liquid at the bottom. So let's just say that this cylinder, the 20-mile tall one, was the same. It was half full, which means that the gas at the top and the liquid gas at the bottom was sharing in equal quantities the inside of the cylinder. So the pressure at the bottom would be more than the pressure, even in the liquid, at the top. Now, another thing came to mind. You know, you may have seen these, what you get in a chemistry lab. They're like a glass flask, not a flask. I don't know the correct term for the equipment in a chemistry lab. I know test tube and Bunsen burner, but I'm not really au fait with them all. Petri dish. So it's a cylindrical glass container, and it stands about, well, let's just say it's 10 inches tall, and it has a base. And if you put you must have seen this, different coloured fluids, and they all separate out because of their densities. Now, okay, there's only one type of gas in the cylinder that I'm talking about, the big, tall 20-mile one. Did I say 20 mile? I hope I did, because I meant 20 mile. Yet, within that, because it will be denser at the bottom, it will, and that's because of the pressure within the cylinder, because of the obvious. If you stand any matter on top of another matter, the weight of that matter becomes apparent, and that's all it is. That's all it is, really. If you put a brick down and you put 4 more bricks on the top of it, the the bottom brick, the fifth one, or the one that we started with on the ground, will feel the pressure of the other four on top of it, and the top brick won't have that pressure. It is really that simple, and it applies to any kind of matter. So there you go. Now, obviously, gases are far freer and able to move around much more easily than bricks in the breeze. And like I said about the shipping forecast, if you didn't hear that, well, I listen to the shipping forecast most nights, and I am told of the pressure variations, and like pressure tries to equalize itself, as does heat, and that is what creates our weather systems, the heat of the sun, and it creates differentials which try to equalize. So there we go, there's my kettle boiling. Excuse me for one moment. Hello. So I'm also making some distilled water at the moment, and I may have said before that I just have a 3-bucket water distiller. There's a big stainless steel bucket which you put water in, about maybe halfway up, and then there's a stainless steel bowl which floats around in that water, which collects the distilled water, which condenses on the underside of another stainless steel bowl, which fits like a lid, but not a tight fit, on the top of the bucket. And you fill that stainless steel bowl, that also doubles as a loosely fitting lid, with cold water. It doesn't stay cold for long. And then as the water condenses on the lid bowl, it drops into the one that's floating, and eventually you take the top lid off, take the middle bowl out, the one that's floating out, which has distilled water in it, and you collect that, and then pour the lid water into the main bucket, because it's already hot, or certainly warm, and so it doesn't have to work so hard to bring that up to temperature. And then you refill the lid bowl with cold water, so it condenses more readily. Simple. The only thing that isn't so simple about it is actually retrieving the floating bowl. As the water, because it's tapered, the stainless steel main bucket is tapered. As the floating bowl, as the water reduces in the tapered bucket, the floating bowl then becomes tighter, and you can't get your fingers underneath the rim. Not only that, when you try to put your fingers underneath the rim, it's fucking hot. So you've got to, I use a cloth or whatever, and it's a bit tricky, and you can spill it, and it's a precious substance when you do it that way. But I can't, because I've got no electricity here, I can't get one of those fancy plug-in ones. I'd like one, I really would, but anyway, you just have to piss with a cock you've got. So anyway, I was talking about pressure, I understand. And weather, yes. And I was talking about, of course, the fantastic the old, I don't know how long it's been going now, for many years, decades, the shipping forecast. Now, like I say, when you understand the terminology of the shipping forecast, you also can deduce that they're giving the game away a little, because they give the distances that you can see. And sometimes it's very little. If it's foggy, if it's misty, you can hardly see any distance at all. But many times they say 20 miles, 30 miles if it's really clear. And we're told that we can only see 3 miles to the horizon if we're on the beach. Now, okay, there are big boats out there where you have an elevation from sea level, but there are also very small boats. So do they say, oh, if you're on a big boat, you can see this far. If you're on a small boat, you can only see this far? Of course not. They say you can see this far, no matter. So they must be referring, I would think, to sea level, to a man standing on sea level, as you would at the beach. So, I don't know. I don't really know that, but you can see much further than 3 miles, so they tell us. So there you go. Well, look, we knew this anyway because, like I've said before, one of my favourite beaches to go on, you can see beyond Hartlepool, and I'm in Skinninggrove Beach. If you look that up in the map, on the map, Skinninggrove is north of Whitby, very close to, let's think, Saltburn. If you go to Saltburn, which is a seaside town north of Whitby, if you go, if you look at that, slightly south, then you will see Skinninggrove, and see how far it is to Hartlepool, and I can see beyond that. And I will take my camera down there and show you what I can see. You know, when I have a little more time, or when it's more suitable, shall we say. So there's no mystery about air pressure. It is what it is. And if you want to buy anything, I mean, Harry Growler said it perfectly. When he rang up to order some gas, you know, some argon, he'll be MIG welding, I suppose. And he said, can I have it without a container? And of course I said, what? Because you can't do that, you know, it's crazy. It's crazy to think that it won't just piss off. And it's also a bit mad to think that air contains all these gases like helium and hydrogen and all the noble gases, really, because they would just do the same thing as the glass vessel where all the denser materials go to the bottom. And of course, helium gas, hydrogen, would just go to the top. It's quite plain and obvious to me. But if you want to know a little bit more about chemistry, Pete and Peter. Now, that's about the end of my time, so see you later, chaps.